All right, so we are going to look at balancing chemical equations. First and foremost is to figure out why we actually need to balance them. This is because of the law of conservation of matter. So that's what we studied with our vinegar and our baking soda lab, where we found out that matter cannot be created nor destroyed. You do need to know that matter can also be a synonym for mass. So those two words are used interchangeably. But what this is basically telling us is before the reaction occurs, you have to have the same mass as you end up with at the end. Meaning, if we're writing an equation to represent our reaction, we have to have the same number of each element, both before and after that reaction actually happens. So this gets to the actual difference between reactions and equations. Reactions are the things that we're actually performing in the lab. We can observe them, we can record data about them, whereas an equation is a written representation of the reaction. So it just shows us what's happening. And as we do more and more reactions, you'll be able to kind of visualize those equations as they're written. To go through and kind of break down a chemical equation, first thing we're going to look at is the arrow. That is called the yield sign. It is what divides up the starting materials from the ending materials. It tells you that some sort of change is actually occurring. Looking at another part, we have the state of matter symbols. G is gas, L is liquid. If you were to see an S, that's obviously solid. The one thing that a lot of students may or may not have seen before is AQ. You need to know that this stands for aqueous, which means that a solid has been dissolved in water. So you need to make sure you realize the difference between aqueous, solid dissolved in water, so now the network is broken up. Ions can move around, whereas a liquid, if it's an ionic solid, is really, really stinking hot. There are two major differences between there, and they are definitely temperature involved. Looking at the left side of the arrow, everything on that left side is considered a reactant, so it's the stuff that you start with or the stuff that you actually use to make the reaction happen. On the right side of the arrow, you have your products. That's what you end up with after the reaction has happened. You do want to make sure you realize that you cannot have a substance on both sides of the yield sign. The reason is because if it doesn't change, then it wasn't actually part of the reaction. So if you were to have methane that you're going to burn in oxygen and you end up with carbon dioxide and water and you have leftover oxygen, you can't put the oxygen on the product side. It's not an actual product, it's just leftovers. So you just have excess over here. Going back to it doesn't change, or if it doesn't change, then it wasn't part of the reaction. Things like that would be called a catalyst. And that, if you remember, catalysts are written above your arrow. So in this reaction with combustion, typically you have heat as a catalyst. So you would draw a triangle above your arrow to show that heat is being the catalyst there. Moving on with our different parts of our equation, two different types of numbers that we use. Subscripts we've talked about before, the little numbers. Those you need to realize we can never ever change a subscript in order to make the equation balance. So if we look at water, water is always going to be H2O, so 2 hydrogens, 1 oxygen. It's never H2O2, never H3O, always H2O. The one number that you are allowed to change in an equation to balance it is what's called the coefficient. So again, we've talked about this, but those are the big numbers that you write on the lines before the substances in the equation. Coefficients are the things that are needed in order for a reaction or an equation to follow the law of conservation of mass. So if we were to put a 2 in front of the water molecule, you need to realize that that 2 distributes or multiplies to all of the different elements in that substance. So that would mean that we would have 4 hydrogens and 2 oxygens. So be careful and make sure you know that you distribute to everything, not just that first substance. very, very quickly, I know that these steps are written on your note sheet, but I want to quickly, like I said, read through them. So steps to balancing your chemical equations, you're going to start with a 1 on the substance that has the most number of atoms, then go on to balance any metals, then balance your nonmetals, ignore hydrogen and oxygen until the very, very end when you're ready to be finished. Hopefully they've already figured themselves out at that point. 5, 6, and 7 are more reminder steps, I guess, but number 5 is you can only change your coefficients, never ever ever change a subscript. We just talked about that. Number 6 is something to use if you get stuck. So if you come across a difficult question or a difficult equation, make a list of the elements that you have on both the reactants and the product side of your equation, and then change those numbers of each element as you add coefficients. It seems kind of silly, but I promise you it helps, and I'll show you an example of this. The very, very last step is probably the most important, because you will get stuck from time to time. And if you're really stuck and you're like, there's no possible way that I can make these numbers match based on my coefficients and my subscripts, then you need to go back to where you started, change your coefficient to a 2, and then restart. So make sure you have an eraser and everything will be fine, I promise. So a very, very quick check to follow your steps. Start with the substance that has the most number of atoms. So that's going to be this third one over here. So I'm going to put a 1 in front of that substance. If I put a 1 there, remember that 1 distributes to every element in the substance. So that means that I have 2 aluminums. And it looks like I only have 1 sulfur, but this little 3, the subscript 3 with the parentheses here, means that this 3 distributes to the things only in the parentheses. So I'm going to take this 3 and times it by 1 to figure out how many sulfurs I actually have here, which is 3. So if I do those first 2 elements, then that means that I'm ready to go on to my next step, which is to balance out my metals. So I have 2 aluminums on my product side, which means I need to have 2 aluminums on my reactant side. Right now, I only have 1, so I'm going to put a 2 in front of it to multiply. I'm going to look at my sulfurs. I have 3 on my product side. I need 3 on my reactant side, so I'm going to put my sulfur. I'll put a 3 in front of that substance. Now, I can go ahead and look at my hydrogen and oxygen. Notice how I waited until the end to do hydrogen and oxygen. I did my metal first, then I did my nonmetals that were not hydrogen and oxygen. Now I'll go on to my oxygen. So again, this 2 distributes to every element in the substance. This 3 only goes to what's in the parentheses. So right now there's a 1 here by oxygen. I'm going to take that 1, times it by 2 gives me 2, times it by 3, which gives me 6. So for my oxygens, I have 6 here. And if I look at this 3, again, it distributes to everything in the substance. So that means that I have 12 oxygen here. So 12 plus 6 gives me 18 oxygen on my reactant side, which means I need to have 18 oxygen on my product side. This one's tricky because I have oxygen in both substances. I have it here and I have it over here. So if I take my 1 times my 4 times my 3, that means I have 12 oxygen from that substance, and I need 18 total. That's what it said down here. So if I already have 12, that means I need 6 more. So I'm going to put a 6 in front of my water, which gives me my 6 oxygen. In this case, it probably would have been easier to go on to hydrogen and skip oxygen, because hydrogen is in 3 of my substances, not in all 4 like my oxygen is. So if I look at my hydrogen, I have 3 times 2, which gives me 6 hydrogen from this first substance. I have again 3 times 2, which gives me 6 hydrogen from my second substance, which means I have 12 on my reactant side, which means I need 12 on my product side. 6 times 2 gives me that 12. So my coefficients, very quickly, if I were to clean up some of this mess, okay, or not, my coefficients were 2, 3, 1, 6. So I hope that helped kind of review balance equations. If you have any questions or something was not quite as clear as you had hoped, please let me know and I will be happy to help you